Hey everyone, I did not realize that that was not the end of the lesson, so let's finish. So what we just did was we completed this triangle JR, equilateral triangle, JRQ up here, given length JR. So here are the steps to actually construct an equilateral triangle that's not inscribed inside of a circle. And if you're not using the side that's given, you're first going to either start with a ray or a point. So here, start with a ray. You're going to open your compass to the length of the segment. Okay. And then you're simply just going to place the compass on the ray and swing an arc. This then will give you the initial length that was given to you. That's going to be one side of the triangle. You use that same compass width, right? You're not changing the compass width. And you're going to put the needle on the new point and swing yourself an arc. Finally, you're going to connect all intersections. So just to kind of show you what we mean here, I will give you a little example. So let's say we have this segment length that's given to us right here. I want to now create an equilateral triangle using this segment length, and I'll call this A, B. Okay, so to do so, it says to start with a ray. So I'm going to put my point down, and I'm going to create a ray. Like so. Okay, I'm going to take my compass. I'm going to open it to be the width of my initial segment, which is AB. Show that I've measured this width by swinging a tiny arc. I'm going to change the color. Swing a tiny arc. Take that over and swing an arc. Now the cool thing about this, if you're using a ray, is you could actually swing an arc that not only goes through the ray, but also either goes above or below to get your first, that second arc needed. So I'm actually going to make my triangle underneath, facing downward. I'm going to make this arc kind of big. And I have to figure out where's my third point. So I'm going to flip my compass around, go to my new point, keep the width the same, and swing an arc down here. Okay. Now I have 3 points. I have a point here, and the intersection point here. I'm going to take my straight edge and I'm going to connect this point to the top there. And I'm going to connect the left point to that arc as well. Let me just change this to not be an arrow. Here we go, and then from here to here. Okay, and then finally, I just want to practice labeling. So it didn't tell me what it wants that third point to be, but I know that this point is A prime. And I know that over here, I have B prime, so I have A prime. And then I have C prime. And I'm just going to label this point A. The cool thing about an equilateral triangle is you could have your triangle facing downward or upward, and both are correct. All right, so that's the steps how to create the equilateral triangle that's not inscribed inside of a circle. So if you're given a side as so, and it says actually construct the equilateral triangle using segment RS as a side. So with that being said, that means that your construction should be on RS. And notice the difference in notation. This has 2 arrows at the end, so that means that it's a line. This has just a segment, so that's segment RS. So off to the right, we have the notation. A line has 2 arrows with then the letters underneath. A segment has just a line, a dash, with endpoints, and then RS. It's understood there are endpoints here, even though you don't see points at the end. So to get this construction done, we're just going to follow the same steps. You, by all means, should probably pause and try this out, but I'm going to work through it. So I'm going to put my endpoint R, my needle on R, my pencil on S, and I'm going to swing my first arc rather large up here. So I know my third point should be somewhere along this arc. To get the intersection, I'm going to take the same compass width, not change it, put it on S, and now have it intersect my arc right here. Perfect. To actually form that triangle, I go from R to the intersection, and then S. intersection. And now I have an equilateral triangle with RS as one side. Okay, and then finally we have this little situation, and I like this. I like this scenario. So Margie has 3 cats, and there is this theory that the cats um, in a room position themselves so that they're equal distance from one another. Now, um, she wants to test this theory, and she notices that she has one cat on her bed and another cat on a chair in her room. She wants to figure out by placing an M, perhaps where Mac, her third cat, could be if this theory is true. So it goes back to the baseball. Where would that third person be to have everyone equal distances apart? We want to know where's the third cat going to be so that it's equidistant from the other 2 cats in the room. So in order to do that, we actually have to form an equilateral triangle. We're going to use that construction. But we don't actually need to make the triangle. We just need the arc mark. So if you want to try this out, go ahead and do so. I'm going to work right now by starting my construction. One endpoint J, the other endpoint S, the needle on J, my pencil on S. And now if you think about it, I could certainly draw an arc down here, but that's not going to be helpful because this is outside the room. So I'm going to focus on only drawing my arcs above. So somewhere over here, I'm going to finish the construction now by flipping it, getting the intersection, so keeping the width exactly the same. Okay, and go up here. Okay, so there's the intersection. I'm not done. It specifically says to place an M where that third cat could be if the theory is true. So my final step here, and that's where Mac could be around the bookcase. Okay. This now does complete the lesson for today. So thank you for listening to the second video. At this point, please email with any questions. Make sure you go onto the Google Classroom and submit the practice for lesson 3.